Hi, my name is David Arnold, and this presentation covers a survival analysis of task completion comparing control and treatment groups. The goal of this analysis was to evaluate whether the treatment group improved developer performance in terms of completion time. So the main objective of this analysis was to compare developer performance between two groups, a control group and a treatment group. Specifically, the key question we are trying to answer is whether the treatment leads to faster task completion. Understanding this can help organizations improve productivity and make better decisions around workflows, training, tools, etc. To answer this question, I used three survival analysis techniques. The first was the Kaplan-Meier curve. They were used to visually compare time to completion between groups. Second, a log rank test was used to determine whether any observed differences were statistically significant. And lastly, a Cox proportional hazards model was used to estimate how group membership impacts the rate of task completion. So what you see here is my Kaplan-Meier chart. This chart shows the Kaplan-Meier survival curves for both groups, the control and the treatment. In this context, survival represents the probability that a task has not yet been completed over time. A lower curve indicates a faster task completion. From the graph here, you could see that the treatment group's curve stays slightly below the control group, which the treatment's in orange, control in blue. This suggests that the treatment group may be completing tasks a bit faster compared to the control group. However, the curves run very close together, which this indicates that the difference between the groups is relatively small. Moving on to the log rank results. So with log rank tests, this tests whether the difference is statistically meaningful. The p-value was 0.39, which is well above the 0.05 threshold. So this means that there's not a statistically significant difference between the control and treatment groups. In other words, even though the treatment group appears slightly faster, we cannot confidently say that the treatment group actually improved, we cannot confidently say that the treatment actually improved performance for the group. Moving on to the Cox model. The Cox proportional hazards model here provides another way to evaluate performance. The hazard ratio for the treatment group was 1.86, which suggests that the treatment group completed tasks at a faster rate. However, the p-value for this result was 0.40. This shows that the finding is not statistically significant. This means that while the treatment group appears to perform better than the control group, the result could be due to random variation rather than a true performance effect. Moving on to some key takeaways here from the analysis. Overall, the treatment group showed some improvement in task completion speed. However, that being said, the difference between the groups was not statistically significant. Because of this, there's not enough evidence to confidently conclude that one group really performed better than the other. This highlights the importance of not relying solely on visual patterns when we interpret results. So now let's talk about some business recommendations. Based on these findings from the survival analysis, I personally would recommend focusing on process improvements rather than assuming that the treatment by itself is the cause of better performance. I think it would also be greatly beneficial to continue to collect more data. Larger sample sizes could, help bring up meaningful differences and articulate them more clearly. Lastly here, I think that you should avoid making decisions based on this data set alone, since the results are, as we mentioned, not statistically significant. So next, ethical considerations here. There are some important ethical considerations when presenting these results of the analysis. We have to make sure we clearly communicate uncertainties. Doing so avoids incorrect conclusions and incorrect business decisions. Also have to remember that visual differences can be misleading if they are not supported by the correct statistical evidence. And additionally, using this type of analysis to evaluate performance metrics must be done carefully. When it's done carefully, we ensure fairness, especially when we're working with smaller data sets. And then here are my references. In conclusion, survival analysis provided useful insight into task completion patterns, but these results do not show a statistically significant difference between the control and treatment groups. Moving forward, as I mentioned, collecting more data and continuing analysis will be important before making any performance-based business decisions. Thank you so much for your time.